Hello, welcome to the short lectures in physics session and topic for discussion in this session is propagation errors. Already we know errors in measurements, various errors involved in the measurements of physical quantities, and now we deal with how to uh, sort out the propagation errors. Propagation errors, when I want to measure a physical quantity, it involves a number of experiments in which various other physical quantities are to be measured, and those values are to be put in a mathematical equation also to get the actual value of the physical quantity what you want to measure. In the process, each measurement involves errors, and all the respective errors are to be considered, and also the mathematical operations whatever we are doing, multiplication or addition or subtraction or division or increasing to the power of something like that, all the mathematical operations are also to be given importance in arriving at the final error in the final physical quantity being measured. So if you take addition, suppose you want to measure a quantity q in terms of two other parameters x and y, which uh, include errors in their respective measurements, that is delta x and delta y of the respective errors in the measurements of the parameters x and y. Then if you see in this slide, q plus or minus delta q, already we mentioned that the measurement is plus minus of the measured value. So depending on the sensitivity of the instrument, my measurement also will be plus minus. So if you know the error can be either on the additive side or on the subtractive side. So it can be either plus or either minus. Suppose 10. Similarly, q is being the quantity what you want to measure, and the respective error, if it is delta q, then the parameter has to be expressed in the way q plus or minus delta q. Because q parameter is the addition of the parameters x and y, that is q is equal to x plus y. So the delta q plus minus delta q is given by sum of x plus or minus delta x plus y plus or minus delta y, the two respective values. Because we don't know the exact value of x, exact value of q, hence the exact value of q also is in error. Then if you see the way we arranged these things, x plus y is nothing but q plus or minus delta x plus delta y. So q get cancelled. So delta plus minus delta q is equal to plus minus delta x plus delta y. That means the error involved in the measurement of q, which is obtained by adding the parameters x and y, is the sum of individual errors. Similarly, if you see errors in subtraction, then say q is equal to x minus y, then also q plus minus delta q is equal to x plus or minus delta x, that is x term, minus y plus or minus delta y, that is the y term. Again q get cancelled, and plus minus delta q is equal to plus minus delta x plus delta y. Again the error in q is the sum of individual errors associated with the measurement of x and y. Here one thing you have to notice is, in both terms we are using plus minus term signs. So if you take only the plus term, plus delta x and plus delta y, then the error obtained in the q term will be the maximum error. So the maximum error is in q, measurement of q is equal to delta x plus delta y. Again sum only, but in the plus side, positive side. Minimum error is given by negative side, minus of sum of the two respective errors, delta x plus delta, negative term of plus minus plus delta x plus delta y. So this you have to remember. One is, so each measurement will have maximum error and minimum error. Plus q plus delta q is the maximum error, q minus delta q is the minimum value value of the q with the minimum error. That you have to remember. If you see this multiplication, say q is equal to x into y, then q plus minus delta q is equal to x plus minus delta x into y plus minus delta y. So if we do this multiplication process, then xy plus minus x delta y plus minus y delta x plus minus delta x delta y. Errors being small, you can ignore delta x delta y. So delta q by, if you divide with q terms, then delta q by q is equal to delta y by y, the plus minus delta x by x, plus minus delta x by x, delta y by y. So approximately that delta x delta y term being error being less, you can ignore that term. So approximately we can say plus minus delta q by q is given by plus minus delta y by y plus minus delta x by x. Again, plus minus signs are used to arrive at the maximum errors associated and minimum error associated in the measurement of q through the measurements of parameters x and y. Here, it is not the directly error, but it is a fractional error. Delta q by q is the fractional error associated with the term q. Delta x by x is the fractional error associated with the term x, and delta y by y is the fractional error associated with the term y. So, in multiplication, the fractional error associated with the term q is the sum of the fractional errors associated with the individual terms x and y. Again, plus and minus are referring to the maximum and minimum fractional errors in terms of maximum fractional errors and minimum fractional error for the term q. Similarly, if you see the error in division, say x is equal to q is equal to x by y. Again, if you do the calculations, q plus minus delta q is equal to x plus minus delta x is the x term associated with the error divided by y by plus minus y. So if you do some simple manipulations, x into 1, that means you take out the x and take out y, then x by y term will come out, and 1 plus minus delta x by 1 plus minus delta y by y, that is 1 plus delta y by y to the power of minus 1. So if we simplify that term, finally we will arrive at the fractional error in the term q, that is plus minus delta q by q, is again the summation of fractional errors of the x and y, that is plus minus delta x by x plus minus delta y by y. Again, the plus minus signs referring to maximum and minimum fractional errors. So even in division, the fractional error, it is not the error, it is the fractional error, like in multiplication of the term q is the sum of fractional errors in the individual terms of x and y. Here again, the maximum in both multiplication and division, the maximum fractional error is given by plus delta q by q is equal to plus sign of delta x by x plus delta y by y. And minimum fractional error in q is given by minus delta q by q is equal to minus negative term of summation of both fractional errors in x and y, that is minus of delta x by x plus delta y by y, as shown in this slide. Now coming to the power, sometimes q is given in terms of x to the power of n. Let us say, for simplicity's sake, we have taken the q is equal to x square. So again, if you use this equation, q plus minus delta q is equal to x plus minus delta x plus minus delta x square plus minus 2x delta x. So x square plus 2x delta x square can be ignored because delta x error is very small value. Delta x square can be ignored. Q plus minus 2x, because x square is again q, so q plus 2x delta x, so that delta q by q is given by plus minus 2 delta x by x. That means twice of the fractional error. Fractional error in the term q is nothing but to the power of square is there. So 2 times of delta x by x. So that is for square term. Twice of the fractional error in the q term is nothing but twice of the fractional error of the quantity being measured, that is x. If if q is x to the power of n, then you can say that it is n to the power of delta x by x. If more terms are there instead of only x, x to the power of a, y to the power of b, z to the power of c, like that terms are there, then individual ones you have to plus because they are all multiplication. So you can say delta q by q is equal to plus minus a times delta x by x because for the x to the power of a term, plus minus b to the power of delta y by y, that is for the y to the power of b term. Similarly, z to the power of c term gives plus minus c z delta z by z. That means fractional error of the final term is nothing but the summation of the fractional terms multiplied by the individual powers. That's how the error propagation errors should be dealt with. Now we'll see few numericals to have a better understanding. If you see a simple pendulum experiment which involves measuring the time periods for different lengths of the pendulum. So if L and T are are measured with the errors. In this example, 3% and 2% are the errors in the measurement of length and measurement of time period. Then you can find out what is the maximum percentage error in L by T square. Here one is T square term is there and L by division is also there. So we have to get the fractional errors. That's the maximum fractional error we will get percentage. So delta L by L to the power of 1, so delta L by L plus twice because T square is there, plus division also plus 1 is 2 times delta T by T, that is 3 plus 2 into 2, that is 7% is the error, maximum error, plus 7% is the maximum error, minus 7% is the minimum fractional error in the measurement of L by T square term. That is one example. If you are measuring the force of a measurement of, you are measuring a force acting on a plate, circular plate of radius, then the errors involved in the measurement of force is F 5%, and the radius, measurement of radius of the circular plate is 3%. Then pressure is equal to force by area, that is F by pi r square. That means F is 1 unit and r square is twice power is 2. So delta P by P percentage is equal to delta F by F percentage plus twice of delta R by V. So 5 plus 2 into 3, that is 11%. Now if a term x is measured in terms of a square b by c square, c to the power of 1 by 3 d to the power of t cube, then we have to find out the percentage error in measurement of x. So delta x by x is equal to a square, so twice delta a by a plus b, only delta b by b, plus in the denominator c to the power of 1 by 3, so 1/3 of delta c by c, and d 3 times other, so 3 times of delta d by d. So if you put all the value of all the given errors of a, b, c, d, 2%, 2%, 4%, 5% respectively, you will get 4 plus for a term, b 2%, 1.1 is the value for the fractional error for the c, and it 15%. So if you add everything, then you will get total percentage error of the measurement of x. But the question what they are asking is, what is the minimum, which quantity is contributing minimum percentage error. So minimum percentage error among these things, among 4, 2 and 115 is 1.1. So the quantity C is contributing minimum fractional error in the measurement of parameter x. And next example, we are making a volume measurement. So the mass and density are measured for making the volume measurement. So 1% is the error in the for the mass, and 2% is the error involved in the measurement of that the density. So as volume is equal to mass by density, and volume is nothing but L into L into L, 3 length dimensions. So 3 times of delta L by L is the percentage error, fractional percentage error for the volume, is equal to mass is 1 term, density is m by d, 1 term. So delta m by m percentage plus delta d by d percentage. So delta L by L percentage is 1/3 of mass, fractional percentage 1 by 100. 1% is there for the mass and 2% is for the density. So 1 plus 2 is 3. 3 into 1 by 3 is 1% is the percentage error associated with the length measurement. We are not concerned about volume now. It is the length measurement because volume we are converting in the length dimensions. Next, current. We know V is equal to IR, so current is measured with 5 plus minus 0.2. Current values are 5 amperes plus minus 0.2 is the error in that. Similarly, voltage is measured 60 volts plus minus 6 volts is the error in 6 volts is the error in the voltage measurement. So the resistance is equal to R is equal to V by I. So delta R by R percentage is equal to delta V by V plus delta I by I current into 100. So 6 by 60 is the for voltage. 6 by 60 delta V is 6, V is 60. Similarly, delta I is 0.2 and I is 5. So delta R by R percentage is equal to 6 by 60 plus 0.2 by 5 into 100, that is 14%. And at 2 intervals of time, some parameter is measured, minus 0.02 seconds, and second time is 4 plus minus 0.202 seconds. So then the value of delta T1, delta T2 to the power of half, square root of that you have to measure. So delta T1, delta T2 to the power of half is equal to 2 into 4, that is delta T1 is 2, delta T2 is 4, actual values to the power of half. So actual value of that delta T1, delta T2 is square root of delta T1, delta T2, that is equal to 2.8284, that is 2.83 to the correct significant, because the values are given only 2.00 like the 3 decimals on there. So we have to 3 numbers, 3 significant figures are there. So we have to reduce this 2.8284 to 2.83 in the correct significant. And error associated you want to do, then half of, because power is half of delta T1 by T1 plus delta T2 by T2. So you will get a value of 0.0075, that is when reduced to 2 decimals, 0.01 is the correct significance. So the actual value of delta T1, delta T2 to the power of half is 2.83 plus minus 0.1. Like this we can solve numerical error, numerical associated with the errors, taking into account all the algebraic operations being carried out and the mathematical equations being used in the particular expressions. Hope this finds useful to you. Bye. See you in the next topic of discussion. Bye.